So we have data of other sizes also. RISC-V supports some like other size data, like char corresponds to a character. If you have to declare a character in C language, it is usually represented in a byte. And we have short integer. It's again a data type which stores the data in the form of 16 bits. Simply integer, and long integer stores the value in the form of 32 bits. So if you have already worked in C language, you might have already experienced defining the type of a variable. Okay, so we have some instructions to load a byte or to load a half word. So when we are loading a byte from a memory, we have two variants for loading a byte. So we can load a byte which is the signed byte, and load a byte LBU corresponds to the unsigned data. What does that mean? Is when you are loading a byte from a memory, which means that you are just loading one byte, and when you are loading it into a register, the register size is 32 bits. Okay, so the first 8 bits will be holding the actual byte that you are loading. What happens to the upper 24 bits? So that will depend on which instruction we are using. If you are using the sign extended instruction LB, then the sign, whatever the sign is, 1 or 0 of the byte, it will be extended. Okay, so the upper 24 bits will either be all 1 or will either be 0. Okay, depending on the sign of the byte. Okay, and if it is LBU or LHU, then it will be all 0 extended. Okay, storing the byte. So we can also store byte or store half word. Here we do not have anything like unsigned or signed, because memory is an array of bytes. We can store a single byte. So for example, here RS2 contains the 32-bit data, the 4 bytes data. We can copy the first byte SB with the help of SB into a specific location in the memory. So we can copy only a byte. Okay, when we use SW, the entire word is copied. When we use SH, the half word is copied, means 2 bytes are copied. Okay, so we have these instructions for memory: load word unsigned, store half word, load half word. So there are a couple of different instructions here. We do not need load word unsigned for 32-bit processor, because when we are talking about 32-bit processor, which means that the register size is already 32-bit. So it does not make any sense to define a number or define a value being unsigned or signed. If it would be 64-bit processor, then if you are loading a value from memory, it would be 32-bit, and then you will decide whether it is unsigned or signed. Okay, so LWU does not hold true in 32-bit processor. Same thing we have already discussed. Load byte or load, it loads a byte from the memory to a register, and store byte, it stores the byte into a register. So here, if this is a memory, you're loading using LB, so it will load the byte, and whatever the sign is, it will extend the sign. LBU, it will just extend zeros. And here, the first byte is copied if you're using SB. If you're using SH, the first 2 bytes are copied into the memory. Okay? Any question? Let's do a quick knowledge check then. So what is the value in T0 after executing the following RISC-V instruction? Focus on the instruction we are using. So read the instruction carefully. Go a stepwise manner. So got it? What's the answer? Okay. Anyone else? Sergio?
I thought D.
Thought, okay. You're not sure? Okay. Anyone else? Okay, so the answer is D. So we are trying to read the data from x0, which is 0, plus 201. So 201, we are actually reading a byte. Okay, so this byte 81 will be copied into a register T0. But since LB corresponds to the reading the data sign instruction, okay, so 8 corresponds to a negative number, 81. Okay, 81 is written as like this. 8 corresponds to this as 0001. Because this is negative number, this sign has to be replicated for the upper 3 bytes. So that's why you see FFFF in your answer. Okay? What if I change this with LH? Okay, let's do this. It makes more easier. So what is the answer now? Okay. So the answer is C. Why? Again, we are dealing with the RISC-V instruction, and the RISC-V has follows a little endian format. So we have to read a word, half word, which means 2 bytes from starting from 200. Okay, so AC 81, and again because of 81, the upper 2 bytes will copy the sign. If I would have replaced here this instruction with LH, so you would be reading 2 bytes from here, 201 and 202. Okay, so do not get confused if you see such kind of variations. And I might also change the convention. Instead of reading little endian, I would say maybe big endian format. You should be able to determine, yes.
What happened if you try to do LH for 203?
203, so next I should have mentioned the value, the next value here. So there must be a 203, 204, whatever the value is. If you do not know, if you're not given any value, you can assume it's a null or something garbage. But it should be reading 203 and 204. Yes. Okay. Good question, yes.
Can you explain where the F comes from again?
F corresponds to what? All ones. If I were to explain it here, 81. What does 8 correspond to? 1. So 1 corresponds to the negative number. And I said LB is used to copy a byte and represent it in the form of as a signed extended data. Here in this slide. Here, LB. Okay, so whatever the sign of this byte number 0 here, which is 1. Okay, so you have to replicate this 1 all the way until the end, 32nd bit. So which means it will be all 1. So how do you represent 4 ones? As F. Okay, so this is the first byte, which is 8 bits, and this is another byte, it's FF, FF, and FF. Okay.